Hello, this is Christy Hanlon, and I'm doing a recording for Math 125 for the Chapter 4, Section 4, the right triangle. So what we're talking about with the right triangle is solving for all 6 pieces of the right triangle. So that is the 3 angles and the 3 sides. So we're trying to identify the values of all 6 of those pieces. So whenever we're given different parts of that, we can derive the other parts of it using different tools. And if one side and any 2 of the other pieces of information are known, we can find all 6 of those. But we can't do it if we only know angles, because if you'll look at these 2 examples, if 2 triangles have the same 3 angles, they can be completely different sizes, and their sides will have different measurements, but they still have the same angles. These are called similar triangles. So knowing only the angles won't work. We have to know at least one side. So we can know 2 of the angles and one side, or we can know 2 sides, or we can know 3 sides. We can know any combination of that, but we have to know at least one side in order to solve all 6 of the pieces of information. Okay, so let's look at how that works. So here's some more facts. The sum of all of the angles inside a triangle is 180 degrees. That's true of any triangle, but it's also true of a right triangle. A right angle, what we're calling C, is 90 degrees. So that means that the other 2 angles must be less than 90 degrees, and they must add up to 90 degrees. Why is that? Well, if it all adds up to 180 degrees and the right angle is 90 degrees, 180 minus 90 is 90. So these 2 angles have to add up to 90 degrees. So that also means that neither of them can be 90 degrees. Because if you have 2 that are 90, then your other angle is 0. That can't happen. So these are both going to be what are called acute angles, which are less than 90 degrees. So you're always going to have 2 acute angles and a right angle and a right triangle. Also, if you notice, this is how it is usually labeled. You usually have your angle over here as A, the one up here is B, and then your C out here is your right angle. And then if you'll see, the little letter opposite of A is a little a, and that is identifying the side A. And then the little b opposite the angle B is the side B, and then of course the side opposite C is a little c, and we'll talk about what that is called here in just a minute. Okay, so here's some more facts. The side opposite the right angle is the largest side. That is because this is the largest angle. We talked a minute ago about the fact that these other 2 angles have to be smaller than 90 degrees because they both add up to 90 degrees. So this side is going to be the biggest side because it corresponds to the biggest angle. It is also called the hypotenuse. I know it's a weird word, but you're going to hear it a bunch during this section. The hypotenuse is the side that is opposite the right angle in a right triangle. And the smallest angle will be opposite the smallest side. That's not always going to be A. It could be B. It depends on the size of these 2 angles. And this may not be completely accurate for this triangle. It looks like A is the smaller side. But whenever you're looking at a right triangle, the smallest angle will have the smallest side, and vice versa. All right, solving a right triangle when you're looking at sides. So we're talking about the little letters right now. A, B, and C, the little letters. Finding sides. The easiest way to do this is to use the good old Pythagorean theorem. Now, what is that Pythagorean theorem? If you've had geometry or trigonometry, you've had to use that before. If you have not had it before, don't worry. It's a pretty simple formula to use. It is a squared plus b squared equals c squared. So what does the squared mean? It means multiply it by itself. So that means a times a plus b times b equals c times c. And you can do this on your calculator pretty easily. There's a little button that lets you square things pretty easily. Okay. So you can't get an answer that is something squared. You have to actually do what's called square root the rest of this information. So that looks hairy, I know, but I promise whenever you put it into your calculator, it's not going to be that complicated. There is a button that lets you take the square root. And the way that we do that on the calculator is with the second button and then the little button that has the square root. And then you're going to do the inside of it. So we'll talk about that whenever we have an example. But this is what it looks like when you use the Pythagorean theorem. And that will give you the value of c. So this can be rearranged to find the value of any of the sides. You just have to use algebra in order to make that work. And you start from the top part here, this a squared plus b squared equals c squared. You rearrange this part in order to solve for either a, b, or c. And when you do that, you end up with c minus a or b, and you get these equations, depending on which one you're looking for. So you're still going to have the square root, but instead of plus inside, you'll have a minus sign. And it'll be c squared minus the other one. Alright, so that's finding the sides, and that's if you have enough information to use the Pythagorean theorem. What that means is you have to have two sides in order to use the Pythagorean theorem. If you have a and b, you can use this first formula. If you have c and one of the other two, you have to use one of these other formulas. Alright, if we have angles, the very easiest way to find a third angle, if you have angles, is to use the fact that they are complementary. What does complementary mean? Well, it means that they add up to 90 degrees. So we talked about the fact that they add up to be 90 degrees. So that means that you can take 90 minus the one that you know, and that will give you the one that you don't know. So you can do that with either of those. And that would be the easiest way to find an angle if they give you one of these angles. Now, if they do not give you one of the angles, you have to use the sides. And that gets into using trig functions. So let's do a little bit of a review here of trigonometry. If this is totally foreign to you, you do not have to memorize all of this. This is just trying to give you a little bit of a review in case you did take trig and you'd like to try to refresh yourself a little bit. So this is putting an angle on the axis. This is your x-axis, this is your y-axis, and you can pretend this is the unit circle. Okay, so this is just putting that triangle, that right triangle, exactly on the axis, the way that it looks. So we have our A, we have our B, and we have our C, and this is angle A. So whenever we're dealing with the unit circle, sine is the y value as a point goes around the circle as it relates to the radius. Now in a unit circle, the radius equals 1, and the radius is this line right here, the hypotenuse, or the C side. And this is our point, this B. So as this point goes around the circle, sine is the y value of that point as it goes around with relation to the radius. Well, in a unit circle, this radius is 1, but with this angle, with this triangle, our hypotenuse is not going to be 1. It's going to be whatever value this C side has. So now we're going to have to figure this out. Sine is going to have a value over the radius, which is this C side. So sine of A, this value, this angle here, is going to be the y value over the C side. So if that helps you at all, that's great. This is a little review of trig functions. If that helps you remember the unit circle and how it was the y value with relation to the radius. Now, if this was complete Greek to you, don't worry. You can memorize the information that you need in order to solve the rest of this. I just wanted to put this out there in case some of you remembered this from trig, and it would help you refresh your memory. Okay, so here we go. This is what you need to know. So you need to write this in your notes because you're going to use these over and over and over for your homework. So you can write them this way on the left or this way on the right, or you can write both. They are the same pieces of information, they're just written different ways. So they are all with relation to angle A, and they are the trig functions using the sides. So they are trig functions with relation to the angle A, and then they are using the sides A, B, and C, those values. Now on this side, on the right hand side, it's got these weird little pieces of words. What do these mean? Well, this one says OPP, that means opposite. So it is the opposite side of the angle A. So that would be A, which is what that says over here on this side. What is it over? It's HYP. Well, we talked about the fact that C, this line, is actually called a hypotenuse. So that is what HYP means, hypotenuse. So sine A is A over C, or opposite over hypotenuse. So sine of A is opposite over hypotenuse, or A over C. So this right here is the exact same thing as this right here. Those say the same thing. Opposite over hypotenuse is saying the same thing as A over C. Alright, so now let's go down to this funny little thing. It says COS. You might want to say cos, but that's cosine. Cosine of A. So we're still talking about this angle A. All of these are talking about the angle A. All of these are talking about angle A. So cosine of A is ADJ. What do we think that is? That means adjacent. So which line is adjacent to A? Well, there are two lines that are adjacent to A, but we know that this one, C, is called the hypotenuse. So it already has a name. So it's not C, it's B. So B is adjacent, and C is our hypotenuse. So cosine A adjacent over hypotenuse is the same as B over C. So if you look at it, it is the adjacent side, the side next to it, over the hypotenuse, the one that's across from the right angle. Alright, now our last one is tangent. That's what this is called. TAN is tangent. This one was cosine. This one was sine. This one is tangent. So this one is a little different. This one says opposite over adjacent. So it is saying opposite, or A, over adjacent, or B. So it doesn't have anything to do with the hypotenuse. It just has to do with these side two. So opposite over adjacent is the same thing as A over B. Okay, so what about these others? These others are the inverses of each of these. So if we have sine, the inverse of sine, look at how these are the opposite. So this one has the hypotenuse over opposite, which is upside down from sine, which had opposite over hypotenuse. This one is called cosecant. And it is the same thing as C over A. And you see how that's the opposite of A over C? It's just turned over, upside down from each other. And you probably guessed this one is called secant. And it is upside down from cosine. And it's here, it's the same, C over B instead of B over C. And this one is cotangent. Same thing, adjacent over opposite. So it is the opposite, upside down. Alright, so make sure you have these written down because these are very important. You're going to be using these over and over and over. So you might want to write them on a card or something, or on the front of a notebook that you look at while you're taking notes, or on another notebook or something like that. Somewhere that you can see it all the time because you'll use this a bunch. Okay, so if we are given this information, how do we solve this right triangle? We are given that angle A is 50.0 degrees and side B is 6.70. What should we do first? Well, the easiest thing to figure out is that angles are going to add up to 90. Angles A and B are going to add up to 90. So we can do what we talked about before and say 90 minus 50.0 equals and that is going to give us 40 degrees. Okay, great. So then we have to figure out the sides. Well, we only have one side, so we can't use the Pythagorean theorem. So that means we're going to need to use trig functions. So which trig functions relate to the relationship we have? Well, it depends. What other side do we want to find first? Let's find C first. Well, if we want to find C, we have to think about which relationship works with which sine function. I'm sorry, not sine function, trig function. So angle A, and we have adjacent, that's what this side is, and C would be a hypotenuse. So angle A, B over C. So which of these has B over C? That would be cosine. So that's what we're going to use. All right. So if we do cosine A, that means cosine of 50.0 degrees equals 6.70 over C, because C is our unknown. Well, in order to solve this, we need to multiply C times cosine of 50 degrees equals 670, and then we need to divide. So I'm just doing algebra here. That's all I've done. So to start with, I substituted my 50.0 degrees in for A and 6.70 in for B. That's how I got here. And then in order to get the C out of the denominator, I multiplied it by cosine. That's how I got this. And then in order to get the C by itself, I took this cosine and I divided it on the other side. So now what do I end up with? Well, I get about 10.423. Now, how do I know how to round that? Well, we've learned in other sections that we have to pay attention to what is given to us in the problem in order to know how to round significant digits. Well, our original problem had 50.0 degrees, and that was 3 significant digits on both of those. So we need to do 3 significant digits for our answer and make sure we round correctly. So if that is a 2, then we're going to leave that 4 the same as it is. That means C is 10.4. So B was 40.0, because we have to have that extra 0 in there in order to have 3 significant digits. And C is 10.4. Now what about A? How are we going to do A? Well, we want to use the information that was given to us to solve it. You don't want to use information that you have come up with whenever you have solved things, because that gives you room for error. You want to use what they gave to you in the problem as much as possible whenever finding the unknowns. Okay, so we have B and A, and we want to find something with angle A. So that to me looks like we're going to need to use tangent. So let's do that. So we can do tangent 50.0 equals A over 6.70. And now to get A by itself, we multiply 6.70 by the tangent. And we get about and that is 3 significant digits, so that is a good answer. Okay, now if we want to check ourselves, what we could do is we could take this value, 10.4, that's our C, that's our lowercase c, the side, and this value, B, 6.7, we could take that and check it and see if it is accurate or close to accurate. And when I do my calculations, it is very close. Because this is the same thing as saying b squared plus a squared equals c squared. That's our Pythagorean theorem. All right. Very good job on our first one. Let's try another. Okay, here's one where we are given two sides. What do we want to do first? Well, since we're given two sides, we can do the Pythagorean theorem. So let's do that. So we have B and C. So that means we can take C minus B. Remember I told you you could manipulate this equation in order to get the different sides. So I could do this, and then I could get my answer to be about now somewhere in there I took this square root. I'm sorry, I skipped that step. I would have had to take the square root of my answer in order to get A. Okay. And then this is what we end up with. So that is A. So now we have A. Now we need to find our angles. So all we have are sides to work with here. We need to find our angles. So we're going to have to use trig functions. All right. So we have B and C. So which of our trig functions can we use with angle A? Looks like cosine will give us angle A. So cosine A equals 5682 over 79.55. Now, that looks interesting, but how do I get A by itself? Well, here is the trick. for that. We're going to do what's called inverse or arc cosine. And there is a button on your calculator that lets you do the little thing above cosine that has the -1. So it's called second. It's up at the top left of your calculator. You press that button and then the cosine button, and then you put in these two numbers. You put in the first number divided and then the next number, and then close your parentheses and press enter. And what that does is it figures out the angle for which this is the cosine. That's how that works. The angle whose cosine is this value. This means is approximately . And the reason I use this many numbers, significant digits, is because that's how many are in my original problem. Okay, so we can do the same thing for angle B, but which of the trig functions do we have to use for angle B? We have B and C. So how would we figure that out? Okay, if we go back here, we can see the relationship of these angles. Remember I talked to you about the fact that this opposite over hypotenuse was the same thing as A over C. So we've been talking this whole time about A over C and B over C. We haven't been really talking about the opposite over hypotenuse and those relationships. But now we need to, because we're talking about a different angle. We're not talking about A anymore, we're talking about B. So we need to talk about these relationships because they're going to be different now, because they are in relation to angle B. So this is a completely different perspective because we're now looking at everything from this direction. We were looking from A, from that perspective, but now we're looking from B perspective. So everything is from this direction, and now we see the sides as they are looking from this way. So now this one is the one that is opposite, so B is opposite, and C is still a hypotenuse, but A is adjacent. So we would rewrite these for sine B . Sine B would be opposite over hypotenuse still, but it's going to be different letters. Opposite is B, hypotenuse is still C, and then if we do cosine of B, it's going to be adjacent over hypotenuse still, but adjacent is now A, and then C. See how that works? And now tangent, opposite over adjacent. Opposite is B, and adjacent is A. So tangent for B is now B over A. So see how those swapped? Those changed a little bit because we're looking from a different perspective. So you can have these trig functions from either angle. So you need to pay attention to what they're giving you in the problem, because it's going to be different sometimes. They're not always going to give it to you from the A perspective. So pay attention to that part. For this particular one, they said B, so we look at the B perspective. All right. So let's go back here and find sine of B. Sine of B is going to be 56. So that is going to mean that B equals and in your head you may be thinking, well, am I going to just get the same numbers? But that's not the case because you're now doing inverse sine. You're not doing inverse cosine. You're doing inverse sine. So make sure you do second and then sine and then divide these numbers. And you should get about 45.58 degrees. And that is angle B. So when you think about these, it is a good idea to relate the opposite hypotenuse, adjacent hypotenuse language, instead of just the A, B, C part. Because you're going to see both angles A and B come into play whenever you have to solve these. So it's a good idea to know both, to understand both, because it will happen for both angles. Because B will have a sine and a cosine and a tangent attached to it also. Okay, this next one is giving us a description instead of a picture of a triangle. A right triangle has an angle of 23.1 degrees and a hypotenuse of 43.5. Find the length of the shorter side. Okay, this one we have to reason through a little bit because it's giving us a few hints like shorter side and an angle, but it's not telling us whether those go together or how they're related to each other. So it does give us hypotenuse, which we know where that goes, but it doesn't tell us the relationship of these other two. So bear with me here. I'm going to walk you down how to reason through this. First of all, let's draw a generic triangle. Pardon my artistry skills. Wow, that is not a straight line. But you know what I mean here. It's supposed to be a right triangle. Okay, so we have our right angle here, and we have these two other angles. So we know from what we've talked about already that those two other angles are always supposed to add up to what? 90 degrees, right? And this is 90 degrees because it is our right angle. So altogether they add up to 180. These two add up to 90 degrees. And if they were exactly the same as each other, you would just take 90 and divide it by 2, right? What would that give you? If you divide that by 2, you get 45 degrees. So that's if they're exactly the same. So if we reason through this and we look at the measurement of this angle that they gave us, that angle is less than 45 degrees. 45 degrees is what it would be if these are exactly the same size. So that's telling us that this is smaller than if they were the same size. So this is telling us that there is a smaller angle and a larger angle. So there is one that has a smaller side and a larger side, because this one is smaller than half. The other one has to be larger than half. Does that make sense? So what that's telling us is that the smaller angle is 23.1 degrees, and the other one has to be 90 minus 23.1 degrees. But it's not asking us for that other angle. It's asking us for the length of the shorter side. So what can we tell about the shorter side now? Well, we talked about the fact that the sides correspond to the lengths, or correspond to the sizes of the angles. So the shorter side is going to correspond to the smaller angle. So the shorter side is going to be right there. It's going to correspond to the smaller angle. And then they gave us hypotenuse, 43.5. So there we go. So we have a right triangle. Let's draw this a little bigger. And even worse. Oh my goodness. Okay, that's okay. Okay, so there's what we have. So now what we have to do is figure out how to solve for x. So what we're going to have to use is trig functions. We need to look at what relationships with this angle, sorry, that should have a degrees, with this angle will give us this unknown. So what it looks like is we have, in relationship to this angle, we have opposite over hypotenuse. Opposite over hypotenuse. And what was that? What do we remember? Opposite over hypotenuse is going to be sine. So I know this is in a different place than angle A, than what we looked at before. We could rearrange this so that it looks like what you're used to. But you do need to get used to it being in different places, because they're going to confuse you, or they're going to try to confuse you on the homework. So make sure that you understand the relationships no matter where they're placed. Okay, so we have these relationships. So what we can do is we can say sine of 23.1 degrees equals x over 43.5. And since our unknown is x, we need to get rid of this 43.5 in the denominator. And if you remember, we do that by multiplying times sine of 23.1 degrees equals x. And we put that in the calculator real quick, and we get 17.07. And if we look at our original numbers, they have 3 significant digits. And we look here, that tells us to round up. So 17.1. That is the length of our shorter side. Okay, that's it. I will be back on Monday. You can contact me with questions, and I'll try to get back to you as quick as I can. I'll be back on Monday. Good luck.